Hi, I'm Chris Young, Chief Technologist covering MicroFocus's strategic accounts. In today's presentation, I'll cover a problem that's common to many organizations, the lack of skilled performance engineers. And I'll be discussing how you can use a combination of automation, AI, and shift left or shift right methodologies to have computers fill in that void. Think of it as a virtual performance engineer. If you're going to have a bot fill in for a human, it's important to understand what that human does. And in the case of performance engineers who help QA how applications respond under load, they conduct four major activities. First, they work with developers and QA analysts to build and record scripts that simulate user load. And then they push those assets up to the execution platform to generate load against that application under test. Then they collect and analyze the data generated to determine response time patterns. And finally, they consult with developers to identify and alleviate bottlenecks, increasing that application performance. And so if we look at this in two phases, really we have everything on to the left that we'll call build and everything on the right that we'll call analyze. And in today's video, we're going to cover the build aspect. Many companies today rely upon microservices to deliver their applications to market. And Swagger Open API, this logo, has become the default standard for documenting microservices. And Swagger has a robust ecosystem of libraries that help developers design, build, document, test, and consume RESTful web services. And you may have seen self-documenting help pages like how MicroFocus documents all of our web APIs. When you click on one of these individual banners, it brings up the documentation for a particular endpoint where you can, stub out some sample code, even use a little button to try out that API call. So once you have documented your API in Swagger in this JSON format, you can include those libraries directly in your web pages and you'll end up with documentation just like this. So one of the other cool features behind Swagger is since Swagger documents those APIs and we can render self-documenting help, we can use that same concept to roll through those documents and use AI to generate unit and functional and load tests directly in the hands of developers without requiring a performance engineer. In this video, you'll hear me refer to this as the gadget. So let's quickly cover the process flow for the gadget. So you have a developer. They're working in Visual Studio, Eclipse, or IntelliJ, and they're developing source code and unit tests of that source code. Then you have your CI/CD tool chain, which consists of a source code repository in Jenkins. And as the developer checks in code, Jenkins sees that check in and then builds that against a test environment. Now it's pushed over to the QA team, who is now going to qualify this application candidate. And so they take those unit tests that were created by the developers and they derive functional SIT or UAT tests from them. And then the performance engineers come in, actually take those functional assets, run them at scale, many copies of them against the test environment. And they do that using Load Runner or Performance Center from MicroFocus. Now, one of the interesting characteristics is to build these scripts, it really takes a skilled performance engineer who's got knowledge of the product as well as some time in order to create those scripts. And this can frequently bottleneck the CI/CD process because the developers are able to check in code faster than the performance engineers can keep up. So to move away from this, this is where the gadget comes in. We put an easy button in the hands of the developers, and every time the developer, changes the Swagger, the easy button is run and it creates a new performance test derived from that Swagger, automatically uploads it to Performance Center without any human involvement. And now you can remove the performance engineer from the equation. It frees up the CI/CD process, and really what you're doing is you're shifting this burden left onto the developers. They're able to load test much earlier in the process against their own machines. And you're also enabling it so that the performance engineer is out of the mix and the human bottleneck is gone. And now Jenkins, every time someone checks in code, can run a performance test. If it passes, it moves it on through the process, therefore enabling continuous deployment. Now, before this video dives too deeply into the gadget, let's talk a little bit about script creation and how we can create that in any set of toolkits. So if you're an admin or a developer and you log in to LoadRunner or Performance Center is the on-prem version, you'll see a little splash page where it's a quick start. If you don't have a script, you can use some common tools to create a script. And so if you have a HAR file that you've maybe recorded inside of the Google Chrome tools, or maybe you have a REST endpoint, there's a wizard where you can type that endpoint in and test it. Or maybe you have a series of endpoints with the data you need to post to them inside of a CSV file. You can upload that Excel and it will automatically create you a script. It also has the capability to accept other common open source formats like Vuegen, Gatling, or JMeter. Selenium with JUnit is supported, as well as MicroFocus UFT scripts. You might even use, if you're familiar with Node.js, we have a library called TrueAPI that allows Node developers to develop their own code. But what we're going to be using in today's video is something called DevWeb, which is a series of utilities and plugins directly to the developer's IDE that allows them to use standard JavaScript to develop performance scripts. So no matter what tool you create your script, LoadRunner or Performance Center is smart enough to figure out what type of asset it is, and it will automatically upload it to the asset library. And as you can see, it will derive the type here, and then that'll be available for developers or Jenkins to use. Here's a little how-to if you want to learn a little more about each of these different script types and how to implement them. But again, we're going to be covering DevWeb, which is will allow you to use any standard IDE and real basic JS files to create your scripts. Now, the gadget was designed with a couple design principles in mind. First off, it's cross-platform. It's able to run on Windows, Mac, or Linux, and the developer will be able to use whatever IDE they're most familiar with. It's all API driven, so if you feel comfortable with REST APIs, you can certainly extend it to meet your needs. It's written in JavaScript, so it's a ubiquitous language that's familiar to most developers. Again, as I pointed out in the last slide, toolkit agnostic, so we don't really care what you originally create your script in, whether it's Selenium, Gatling, HAR files. And then finally, everything that the gadget does is meant to minimize clicks and take away those mundane tasks that the developers might become bored with. So let's jump into a demo of the gadget. Before we get started with the demo, let me orient you to my setup. So I've gone to the MicroFocus Marketplace and I've downloaded LoadRunner, also known as DevWeb. This is the IDE plugin and toolkits that allow you to performance test from your local PC rather than involving a server. It runs on Mac, Windows, and Linux. You can see I downloaded the Mac OS version and installed that directly to a DevWeb directory underneath my applications folder. I've also downloaded a Grafana dashboard. You can see this JSON here. I had Grafana installed locally, so I imported that dashboard, and this will create me a visual interface for monitoring what's going on as I do performance testing. The last piece is a project for us to get started, and here are two versions on my GitHub account. One for LoadRunner Enterprise, which is the on-premise version, and another for LoadRunner Cloud. Grab these, download them, extract them, and then now it'll be time to work in our IDE. We're in our IDE, and because this is a Node project and the gadget is written in Node, you can see there's an app.js document with all our code and workflow in it. But we might want to make this a little bit easier on ourselves to take some of the most common development tasks and put those at our fingertips. So, the ability to go under terminal and then run a particular task here and have a list pop up. So because I'm using Visual Studio, that's done through this tasks.json profile. And as you can see, I've created a couple here. I've created the ability to run a Node document directly, as well as Swagger parse a particular file. It'll feed it. It'll call Node, but it'll feed it through this JS that will parse the Swagger file. In addition, there's pointers to those DevWeb utilities that we talked about earlier. So you can see if I want to do a single run from my box, it will call this DevWeb utility here. And then there's two other utilities that are built inside of here, a ProxyRecorder and an OfflineGenerator. which we will cover subsequently later on in the video. So let's start off with a quick example showing you how to use our IDE to parse a Swagger file. So underneath this test folder here, I have a JSON Swagger example, and as you can see, it uses those public REST interfaces, 2 of them, number to words, and then there is an all uppercase with token. So let's start parsing some Swagger. So over here in my test directory, I have a Swagger JSON, and as you can see, it points to a public-facing API. For the benefit of this video, here are the 2 APIs that we're going to consume. The first one is this number conversion service. If we feed it an input of 10, it will output the alphanumeric TEN. The second is a text casing service. If we feed it some parameters, for example, this 10 and a delimiter of dash, it will uppercase it and put dashes between each of the characters. So these 2 APIs are documented inside of this Swagger example. You can see here's that number to word function along with any of the calling information that it needs, as well as the all uppercase with token. Now parsing one of these Swagger documents is very easy. All we have to do is make sure that we're selected, go up to our terminal, and then run task. And then as you can see, we've got this Swagger parse. It's going to call the node.js command, which will parse that. You can see it created a brand new directory over here, and we'll start discussing the contents of this directory. So the first file that was created is this main.js. And as you can see, this is the function that's going to call all of our different APIs. So we had our original Swagger JSON. One of the other value-added functions that I'll point out quickly is this source document was in JSON. It can accept YAML, it can accept JSON format, it can even accept a URL, which I'll show you a little bit later in code. But one of the things that it does, this JSON might not be human readable, so it converts it also to a YAML output that's very human friendly. So and that will always be called swagger-source YAML inside the directory. So back to our main.js, you can see our original functions. Here was our number to word function. We have the operation ID and the summary. What's happening here is each of these different values is getting transposed directly into the JS. So up here in this little comment section, it's showing us the number to word along with the summary information of that API. It's also created us the base URL details. So everything was extracted, host, base path, and the scheme. This all came from the upper section of the Swagger file. In addition to that, any headers that we have end up getting translated directly into right here in the body. So we covered the URL, we covered the headers. Any of the other details, such as a stubbed out body, will come from the bottom. So you can see if we scroll down to the bottom here, there's an object that is going to be called UBI number with a default value of 0. It pulls that information in and stubs out a body for you to edit. Everything will be based upon defaults. So if a default value was provided inside of here, it will stub that out. Otherwise, it will leave a placeholder. So the next handy feature that I'll point out are these transaction markers. And as you can see, whatever the operation ID was here, it created a transaction marker where it's going to do start and stop timings for the execution of these values. So you can see here we've created one called number to words, and we're starting that transaction when we begin our web request, and then when we're done parsing that web request, we're going to go ahead and stop it. Then we do the same thing here. Second transaction called all uppercase with token, a start and a stop. And where that's going to become useful is when we actually do a run. So I'm going to go ahead and expand this terminal window just a little bit, and let's go ahead and run this through one time locally with my PC. So if I go up here to my terminal, I can go ahead and click the DevWeb single run, And when I run this, it'll actually run through that script, do a performance test, and you can see it's bringing us a little table back here with each of those transactions and how long each transaction took. So from the start and the stop time took 89 milliseconds to execute the all uppercase with token function, and the number to word executed in 208. You can see both of these transactions have passed. So let's close out our output here, and let's move on to the next feature that's inside of our script. Let's talk a little bit about dynamic values. Let's say that you wanted to feed in some values from maybe some test cases from maybe a CSV file here. So you can see we have created a CSV file here inside of the directory. It has two values, value 1 and value 2, and then there's a couple test cases inside of here, and we've coded 3 of these test cases to pass and 1 of them essentially to fail. If I go over here to my parameters.yaml file, that's the file that actually defines how these are read into the JavaScript. So you can see we're going to read data.csv. We're going to have 2 values, value 1 and value 2. These are going to be the JavaScript variables. They're going to source from these columns inside the file, so capital value 1 and capital value 2. If we pull that information, over, you will see that our parameters, whatever we've called in this JavaScript variable, will be fed up here into the top of this particular main.js. So I've got value 1 and value 2. We're going to use value 1 as the expected value that we're going to send in. We're going to send value 2 is what we're going to expect to come back from the second API call. So we're going to chain these. We're going to chain these together. So the first thing I'm going to do is go over here, and we had that default value that came from our Swagger. That was a 0. Let's go ahead and change that to be value 1. All right, and then the next thing we're going to do is we've gotten the value from our first web call. We're going to go ahead and take that down and substitute that inside of our second web call. So essentially what we're going to do is we're going to take a value that comes from the CSV file. We're going to feed that into the first API. Then we're going to take the value, the result of the first API. We're going to feed that into the second API and then see what the return is. Now, down here at the bottom, there's a little comment here. You may or may not want to use this block. This is a simple assert statement. What it's doing is it created a third transaction for us inside of here, and it'll give us some values here. You can see that we've labeled this as trans 0, and what it does, it actually prints us off the value that we're sending in, the expected value that we're getting back, that we have in our test case is value 2, and then what we actually receive from the second API call. And then what we're doing is we're comparing those two values. Did the second API call, the value returned by that, did it match what was expected? And if so, we're going to pass the transaction, and if not, we're going to fail the transaction. So I'm going to go ahead and save this, and now let's work on one other YAML file, and we'll go ahead and run this as a real performance test. So here we have our scenario.yaml. This is what defines how the scenario is going to run. So you can see we've got one V user and for a certain duration of 5 seconds. Let's go ahead and make this 10 seconds. And as we're running this, I will also point out that there's been, in our last run, there was when we ran that single DevWeb run, there was a results table that was created, or results folder that was loaded here, and everything is written to a SQLite database. So one of the things that we can do is we can actually open that database and see the transactions that we ran. So if I scroll down in here, you'll see here's our transactions, and if we pull that up, pull it over, there were our 2 runs. So that matched exactly what we had in the text output. You can see here was that 208 and the 89. We'll go ahead and close this out, We are now going to run this with 10 users, or for 10 seconds with one user, and we're going to loop through all of those scenarios from our file. So here we are on our main.js. Let's go ahead in our terminal. Let's do a run task. This time we're going to do a load run, and as you can see, it's running through here. It's doing some test cases, and as it loops, now it's finished. It ran for all those seconds. And let's go ahead and reopen our database. We'll go ahead and check our transactions. Close these windows out. All right, as you can see, here's a number to word function, the all uppercase with token function. So we sent in a value of 0. We expected to get 0 back. That's what we received. Therefore, this function passed. We sent in a second round. You can see now we've moved forward and we've sent in a 1. We expected to get a 1. We received that. And then finally, our two worked, but when we got to 3, that was the use case that failed. And as you can see, we sent in a 3. We expected to get 3 back, but what we actually received was this 3. Therefore, the test cases failed. So now that we've shown how to do a simple load test running with one virtual user, let's make this a little more complex, and let's add our Grafana database to the mix. I'm going to go ahead and close this out. We'll go ahead and come back over into our test. Again, that SQLite database has been is where the data has been dropped, but we're also dropping it to an InfluxDB, which Grafana is attaching to. So let's go back into our scenario YAML, and instead of doing 1 vUser, let's do this with 5 vUsers. And one of the neat things about DevWeb is it'll allow you to use up to 50 virtual users against your local machine without having a server instance of the product. So we're gonna go to 5 vUsers, and we're gonna run this for a total of 60 seconds. Now before I move over here, I'm gonna go into my load runner developer, and let's just make sure that in our Grafana database, we'll refresh this as on a 1 second interval, so we'll get like real-time graphing of what's going on, as we run this. So we've gone ahead and changed this to be 5 vUsers for 60 seconds. We'll save it. Go back to our main.js. Let's run our terminal, and then let's begin running a load test. As you can see, it's pulling now. You can see all the hits that we're getting. So here it's calling that all uppercase with tokens and our number to word function. Here are all of the different hits that it's running. The running virtual users, you can see we're up to our maximum. Here are our transaction response times. If we scroll down into our database here, we should be able to see some of the information about the HTTP responses, and then here's our throughput along with the bytes sent. So we can go ahead and we'll go ahead and stop this procedure, and then we'll see everything kind of cascade back down to 0. So now that you've seen how to produce a DevWeb script via Swagger parts, let's also talk about how to do it via app.js. If I move over here into this file, you'll see that app.js makes a reference to include this loadrunnercloud.js function, and inside of there is some self-documenting help that talks a little bit about a Swagger object, and one of the methods is the toDevWeb method. And in this case, you can see if you hover over that method, you'll see that it has a source and a destination. So the idea is here you can feed it a physical file path, either to JSON or a YAML formatted file, but you can also provide a URL, which is pretty neat if you have those published to a document repository or something like that. Instead of you having to go manually download the file and bring it over and create a local copy, you can just point it to a URL and let Node handle that for you. In either case, You provide it the source, either local or a URL, and you provide it a destination folder name, and it'll do exactly what happened when we clicked on it. So now that you've seen the Swagger parser in action, let's cover one additional topic, which is what if you had existing test case scenarios for maybe functional test scripts. So if you're familiar with a really common one is the Selenium IDE. So if you go over into Google Chrome and you were to pop open a Selenium IDE, you would get a script that you would get a toolkit that looks something like this. So here I have created a Selenium script. There's another video that will go into much more detail on how I did this, but I have a sample functional script that executes a workflow against a series of web pages. So just to show you this workflow inside of Selenium, I recorded this in the Chrome browser, and if I click the play button, you'll see that it goes over to a fictitious site called Automation Practice. It clicks on a blouse, it adds that blouse to cart, and then it clicks through the cart a couple pages. And then the final thing that it does is it essentially tests the last page to see if the word authentication was inside of there. So we want to duplicate this script and turn this into a DevWeb script. So I'm going to show you how to quickly do that with some of the toolkits that are available inside the Load Runner Developer toolkit. So let's close this window. We have our Selenium IDE open here, and I'm going to come back into my IDE. I'm going to clean this up a little bit. Let me close this out. And the first thing that I'm going to do is I'm going to come right over here into my terminal, and I am going to set up my PC in a proxy mode. So we have this feature called ProxyRecorder, and if I click this, what it's going to do is it's going to set up my machine as a proxy server, and then in just a moment here you're going to see it's listening on a particular port, 8156. And what we're going to do is we're going to take that Selenium script that we that we have available here. We're going to set up my network so that instead of going through a regular network connection, we're actually going to proxy it through my machine. So right now I'm coming over into my machine and I am setting up a proxy. I'm going to set this as a web proxy, and you can see that it's going to proxy any of the traffic through that local host 8156, which DevWeb is listening on right now. So I'm going to say OK here and apply that change, and now I'm in proxy mode. All I have to do in order to get a DevWeb script is to simply run this. And as you see it running, notice how it's capturing all the traffic that's navigating through the screen. So as it's clicking and executing the workflow behind the scenes, all that information was cataloged right here. So I'm going to go back over into my terminal, and I'll go ahead and hit the enter key, and you can see that it stopped recording and it produced me a HAR file. This would be the same as if I produced a HAR through the Google Chrome tools, but I essentially played the Selenium IDE and turned it into a HAR file. Now to make this into a DevWeb script is very trivial. So I come back over here into my terminal. I have that HAR file that was created in step 1. I simply click on it, go back up to my terminal, do a run task, and we're going to do this offline generator. And now that's going to take everything that was recorded in that HAR file, and it's going to produce a DevWeb script called ProxyRecorder. So it's exactly the same files as before. See our main.js. Let me close a couple of these out so it's a little bit easier to view. You can see here's each of those different steps, with each of the web requests and the responses to go along with them. And that's how easy it is to convert a Selenium, Gatling, any script. I'll also point out that this can work just in a in a regular browser window as well. So right now let me go back in and let's delete this HAR file, and let's set us back up into proxy mode. and now we're listening. I've kept my network connection where I'm still proxying. So if I come right over here and I go to that automation practice, anything that I do, let me make this a little bit smaller so we can see it capturing the window inside of here. If I scroll through here and I click this add to cart and I proceed to the checkout, you can see it's capturing each of those details inside of here. And there we go. Let's go ahead and stop it. Again, we've got our HAR file, and it's trivial to turn that HAR file back into a DevWeb script. And that's it. That's how to use Swagger to generate script files and generate DevWeb scripts, as well as take functional test assets and convert them into DevWeb. So that concludes our demo of how to convert Swagger into DevWeb load testing scripts. There are longer videos available that go into much more detail. And as always, you can hit me back at chris.young@microfocus.com if you have any questions.